Welcome to this module on next token prediction, one of the most important concepts in understanding how generative AI works. If you've ever wondered where AI answers actually come from, this lesson provides the answer. When people use tools like Microsoft Copilot, ChatGPT, Claude, or Gemini, it can sometimes feel like the AI is thinking, reasoning, or looking up information just like a human. But that's not exactly what's happening. At the core of every generative AI system is a simple but powerful process called next token prediction. Understanding this concept will help you become better at delegating tasks to AI, evaluating AI outputs, identifying potential mistakes, knowing when to trust AI and when to verify its responses. Let's explore how it works. What is next token prediction? At its core, generative AI is a prediction engine. Its primary job is simple. Given everything that has been written so far, predict what should come next. A token may be a word, part of a word, a symbol, punctuation mark, a small piece of text. AI generates responses one token at a time. For example, if a sentence starts with, "The capital of France is," the model predicts that the most likely next word is Paris. Then it predicts the next word after that, and then the next, and the next. This process repeats continuously until a complete response is generated. What appears to us as intelligence is actually the result of millions of highly sophisticated predictions happening in sequence. AI is not a search engine. One of the biggest misconceptions about AI is that it searches a database every time you ask a question. In many situations, that isn't true. Unless the AI has been specifically connected to external data sources, websites, company documents, or search systems, it is not looking up answers. Instead, it is generating text based on patterns learned during training. Think of AI as an extremely advanced autocomplete system. Just as your smartphone predicts the next word while you type, AI predicts the next sequence of words on a much larger and more sophisticated scale. This distinction is important because it explains both AI's strengths and its limitations. Why AI can be so impressive? Because generative AI has learned patterns from vast amounts of information, it can produce remarkably fluent and natural responses. This capability allows AI to write emails, create reports, summarize documents, explain concepts, generate ideas, convert information into different formats. For example, if you ask AI to explain basic cybersecurity concepts or summarize a meeting transcript, it will often perform extremely well. Why? Because these are common patterns that the model has effectively learned during training. This area is called the capability zone. Understanding the capability zone. The capability zone refers to tasks where AI has seen similar examples many times during training. Examples include summarizing content, rewriting documents, translating text, drafting professional emails, creating meeting notes, explaining common topics, brainstorming ideas. In these situations, the patterns are strong, familiar, and well-established. As a result, AI can often generate high-quality outputs quickly and consistently. These are generally safer tasks to delegate to AI. Understanding the limitation zone. However, not every task falls within AI's comfort zone. As tasks become more specialized, rare, or unusual, AI moves closer to what we call the limitation zone. For example, highly niche research topics, rare technical domains, obscure historical events, specific statistics, exact citations, newly emerging information. In these situations, the AI still generates answers confidently, but because fewer reliable patterns exist, the quality of prediction may decline. The response may sound convincing while containing inaccuracies. This is where careful human review becomes essential. Understanding hallucinations. One of the most discussed limitations of generative AI is something known as a hallucination. An AI hallucination occurs when the model generates information that appears factual, but is actually incorrect or invented. For example, AI may generate a citation that doesn't exist, an incorrect publication date, a fabricated statistic, a fictional URL, a quote somebody never said. This happens because AI is still performing next token prediction. The model is generating what looks like a plausible answer based on patterns rather than verifying whether that information truly exists. It's important to understand that hallucinations and fluent writing come from the same underlying mechanism. The process that makes AI creative and useful is the same process that can occasionally generate inaccuracies. Strengths and weaknesses come from the same mechanism. Let's look at both sides of next token prediction. Strength. Next token prediction enables AI to white heavy checkmark generate natural language. White heavy checkmark summarize large amounts of information. White heavy checkmark adapt to different writing styles. White heavy checkmark draft professional content quickly. White heavy checkmark explain concepts clearly. White heavy checkmark connect ideas across different subjects. Weaknesses. The same mechanism can also lead to warning hallucinations, warning inaccurate facts, warning inconsistent reasoning, warning invented references, warning overconfident mistakes. The important lesson is that strengths and weaknesses are not separate systems. They come from the same generative process. High-risk areas that require verification. When working with AI, some types of information require extra scrutiny. Always verify. Names of people, dates, statistics, research papers, legal information, medical information, citations, URLs, quotations. As a general rule, the more specific the claim, the more important it is to verify. A broad summary may be reliable. An exact figure, publication, or source may require validation. How modern AI tools reduce errors. AI companies continuously work to reduce hallucinations and improve reliability. Modern AI systems often include features such as citations and source references, allowing users to trace information back to its original source. Grounded responses, connecting AI answers to approved documents or trusted databases. Confidence signals, enabling AI to express uncertainty when information may be unreliable. Verification systems, using additional checks and validation processes before delivering outputs. These improvements help reduce risks, but they do not eliminate the need for human oversight. Applying discernment and delegation. Now let's connect this concept to the AI fluency framework. Discernment. Understanding next token prediction helps you evaluate AI outputs more effectively. Instead of asking, does this answer sound good? Is this answer accurate and verifiable? Delegation. Understanding capability and limitation zones helps you decide which tasks are appropriate for AI. Tasks deep within the capability zone can often be delegated confidently. Tasks closer to the limitation zone require more human review and oversight. This allows you to use AI more efficiently while managing potential risks. Conclusion. Let's recap the key lessons from this module. Next token prediction. Generative AI produces responses by predicting the next token based on learned patterns. AI is generative. It creates responses rather than simply retrieving information like a search engine. Capability zone. Common, familiar tasks often produce strong results. Limitation zone. Rare, specialized, or highly specific tasks may increase the risk of inaccuracies. Hallucinations. Confident-sounding mistakes occur because AI is generating plausible content rather than verifying facts. Human verification remains essential, especially for dates, statistics, citations, legal information, business decisions, and other high-stakes content. Remember, understanding next token prediction helps make AI behavior more predictable. Instead of being surprised when AI makes a mistake, you'll understand why it happened, where the risk exists, and what actions to take. That insight is a critical step toward becoming a confident and effective AI collaborator.